In this demo, I'll be showing you how user input can be gathered so you can make your programs interactive. I'll be creating a program that accepts user input twice, and then it'll take that user input and capitalize it, and then just display it back to the user. So it'll be a simple program, but it'll be a great demonstration of how user input can be gathered. To get started, we need to use some functionality provided by the standard library. We're going to use the standard library module called I/O. I/O is short for input/output, and in this case, we want to use the input functionality to gather user input. Next, I'm going to create a function called getInput, and this is the function that's going to be gathering the user input. It returns a result from the I/O module, and the return type is going to be a string. Normally with results, you can just put in result, and then you'll have your successful type, comma, and then your error type. Input/output has so many possibilities of things going wrong that there's a special result provided by the I/O module that automatically has the error type defined for you. So you don't need to include the error type when you're using an I/O result because the error type is already provided. So we're only providing the successful data type, or the OK in this case, and it's going to be a string. In our body, we're going to create what's called a buffer. A buffer is just some space set aside that some other functionality can use and operate with. In our case, we're creating a buffer that is a string buffer. So this is just an empty string, and we'll be using this buffer in later part of our code. Buffers have to be mutable since we're going to be modifying the buffer later on. We'll now use some of the functionality provided by the I/O module. I'm going to use the standard input function. So this is just short for get the standard input. And what that does is it allows you access to the terminal. So when the user types in information, it can be available to our code. I'm then going to call the readLine function after that. And I'm going to allow the function to borrow our buffer mutably. So what that means is this readLine function, which does what it says, it reads one line of input from the standard input. It's going to read a line and then save that line into this buffer that is borrowing. So you can borrow without mutability, which we've been doing so far, or you can have a mutable borrow, as in this case. When you have a mutable borrow, the initial variable must be mutable, and the function that accepts the mutable borrow must also be specified in their function signature. After those conditions are satisfied, the readLine function will be able to access this buffer in a mutable fashion and change the contents of this buffer. Once the readLine function changes the contents of the buffer, we can then refer to this buffer here, and it will have the user input. You can see that we have a question mark operator here, which indicates to us that this function may possibly fail. So if this fails, we will return an error from the function, and the data will not have been read from the terminal. However, if the data is read properly, then it will be automatically available within our buffer. So to get the data from the buffer into our program, all we need to do is just return it. So we'll return it in an OK, because remember, we're returning a result here. So we return an OK, and we'll simply return the buffer. When you're doing a readLine function here, as we are, when you press enter, the enter is actually included as part of the data. In my case, I don't want to include that data, so I'm going to call the trim function on the string, and trim simply trims any white space. So if they enter multiple spaces before or after the text, and when they hit the enter key to submit their text, all those blank spaces are going to be removed. I also need to take ownership of the buffer again, because when we do trim, it just creates a slice because the data is all there and it only needs to return the data that is not empty spaces. So we take ownership again. That way we can return a string properly. Now that we have our input function created, we can create our main function. So I want to have two inputs gathered by the user. So I'm going to create a vector called allInput, and we'll just make an empty vector. Notice how it's mutable because I'm going to be adding data into it from this getInput function. Next, I want to track how many times the user has input some data. I only want them to be able to do it twice. So I'll just call this times input. That'll be the number of times that they input data. I'm then going to create a while loop. So we have while the number of times that was input is less than 2, we're going to perform some actions. Within our loop, we're going to match on the getInput function. We know that the getInput function returns a result, so our possibilities are OK and error. For our OK variant, we're going to just call this words. So this will be whatever words the user typed. And we will then perform multiple actions. We can perform multiple actions when we have a match arm by, instead of placing the action directly after the fat arrows, we put curly braces, and then everything within those curly braces will be executed as part of that match arm. I want to add the input to my vector, so I'm going to call the push method on the vector to push the words. And I also want to ensure that I don't loop forever, so I'm going to increase my times input by 1. We can use plus equals 1 as a shorthand for taking the times input and then just adding 1 to it. So this is just a shorthand. You can do minus equals, times equals, all the mathematical operations you can reassign using this notation. If an error occurs, I want to know what happened, so I'm just going to call it E, and that'll be the description of the error. And then I'm going to do a print line, and I'll just say error, and we'll print out the error message. Finally, we want to actually capitalize our input. To do that, I'm going to create a for loop, and I'm just going to do a print line, and I'll print the original data, and then I'll also print the capitalized data. And this will be input, and this will be input.to uppercase. Before running the program, let's take a walk through it since we have a lot to unpack. First, we're using the standard library here, and we're using specifically the IO module. When we have a using statement such as this, it allows us to access this part here directly in our code, as we can see here. If we hadn't done that, we would need to type in standard and then the 2 colons every time we want to access IO, but doing it this way allows us to access it directly. Next, we have the getInput function, which is used to get input from our user. It's returning a special result that's supplied by the IO module. This result has the error type defined automatically for us, and we only need to define which type is used for the successful variant or the OK variant. After that, we're creating a mutable buffer. A buffer is just a space set aside that we can work with later. It has to be mutable since we're going to be modifying it later. We're creating a string buffer. So our buffer here is going to be able to hold string data. Next, we're going into the IO module, and we're calling the standard input function. The standard input function provides a data structure that can be read to read data from the terminal. We're calling the function here, and as you can see, we immediately have a dot. This is called chaining functions. So the standard input returns a structure, and that structure has functionality defined on it, specifically the readline function. When structures define functions like that, we can chain them as such. So we can chain them indefinitely using more dots, as long as the structures returned have functionality defined. This makes the code much easier to follow and to read. The readline function is called here, and it borrows the buffer mutably. So here we're borrowing it, and we're mutably borrowing it. That means this readline function is going to be modifying this buffer since it's mutable here. The readline function itself is simply going to read input from the terminal, and once the user hits enter, then the data will be placed inside this buffer. The readline function returns a result, so we have a question mark operator to work with that. The question mark operator will automatically return an error immediately if this function fails, and if it doesn't fail, if it's okay, then the data the user input will be placed into this buffer, and it will be available within our code. Lastly, we are returning an OK because we have to return a result. So the OK variant is part of the result enumeration. We're returning the buffer itself, which is a string. We're calling the .trim function on the string, which will remove any white space. So white space would be spaces, tabs, and new lines. The reason we do that in this case is because when the user submits their text on the readLine function, they have to press enter. And that enter is included in the buffer, which means they'll have a new line at the end. We use .trim, which will remove that new line. This trim function returns a slice of the string, because to remove the spaces, all you need to do is ignore parts of the string. So it just borrows the string and returns a slice. But our function returns an owned string. So to get an owned version, we just type in toOwned to call the .toOwned function, and we will then get an owned string back, and our function will then work properly. We'll now go into the main function. The main function has two mutable variables. The first one is all input, and it's simply an empty vector. This will be where our input gets placed that we can then operate upon later. Our times input variable represents the number of times that the user has input data, and we only want them to input it 2 times. Next, we have a while loop. So while the times input is less than 2, we're going to match on our get input function. Our get input function returns a result. So we're matching, and we need to consider the OK possibility and the error possibility. On the OK possibility, we'll get our data back as a string. And in that case, we're going to execute multiple different things. We can do so using the curly braces. We're going to add the words into the input vector by doing allinput.push. .push is used to add data to a vector, and we simply push these words onto the vector. We then increment the times input variable by using the shorthand plus equals and increment it by 1. If an error occurred while we were calling our get input function, as shown here, then we will just print out the error. The information will be displayed to the terminal. We're not going to increase the times input, so the user will be allowed to input data again until they do not get an error. Once we've gotten our 2 pieces of input, this will evaluate to false and we'll exit out of the loop here. Finally, we have a second loop, which will iterate through all the input. So for each input in all input, we're going to do a print line, and we're printing out the original data here, and that'll print out here, and then we're printing out capitalized data right here. So we'll take the input and call toUpperCase to make a capitalized version, and then it'll be printed out there. I'm going to run this code, and we'll hope everything works okay. As we can see here, the program is currently running, so I'm going to type in some information. I'll type in hello there. I'll hit enter, and then I can enter data again because I need to do it 2 times, and I'll say goodbye. I'll hit enter again, and here we have the original is hello there, and the capitalized is hello there in all caps, and the same thing with goodbye. This demo had quite a lot of new things. We had the IO module, we have buffers, multiple new functions, possibly the trim function as well. All of these things are available in the standard library documentation, and it's always handy to keep a web page open with the documentation available. That way you don't have to code all of this from memory. You can just refer to the documentation, see how it works, and then easily use it in your code. This will allow you to more easily focus on your actual program and what you're trying to do, instead of having to worry about whether or not you called the correct function or if you spelled it correctly. So the documentation is an invaluable resource that can be used to speed up your programming. This concludes the demo on gathering user input. I'll see you in the next presentation.